So we'll go ahead and then discuss the new relation of the spinal cord, new relation in the spinal cord development. So by that virtue, I mean, where does the neurotube come from? And out of this neurotube, which point gives us the spinal cord? Yeah. So of course, you know my name. What will be our objectives for the sessions? And for the session that we're going to have today, we are going to discuss the embryonic origin of the nervous system. We're going to describe also the process of primary and secondary neurulation, given the fact that we have the neurotube coming from both primary and secondary neurulation. We need to discuss the processes of both. And then we also need to describe uh, the neurocrest derivatives and the associated anomalies and what is the embryological basis of these anomalies. Then we describe the various parts and derivatives of a neurotube. And then we'll also go ahead and talk about the differentiation of caudal neurotube to form the various components of the spinal cord. At this point, objective number 5, we'll be talking about the development of the spinal cord. Then we also check on the positional changes in the spinal cord levels. Yes. So we'll go ahead and then discuss the congenital malformations of the spinal cord. So I'll take us to the three germ layers. The three germ layers. Maybe someone can put in the chat box how many germ layers, what are the derivatives of the ectoderm? What are the derivatives of the ectoderm that you know? Yeah, you can put in the chat box meanwhile. What are the derivatives of the ectoderm that you know to make the discussion interactive? The good thing is that I know some of us. So I expect Rono, Jonathan, Moses, like the likes of the people that I know to at least come up with some that you know, and some of them actually will describe them. So what do you know what are the derivatives of the surface ectoderm that you know? Um, Ideally, epiblast can be a derivative of ectoderm. Like the epiblast is the one that gives us ectoderm. Yeah. So Jonathan, you're right. Surface ectoderm gives us the epidermis, correct? And then the neuroectoderm gives us the neurotube. So at this point, you need to appreciate you have two germ layers. The two germ layers are epiblast and hypoblast. Then after that, you go to the three germ layers, which are now the surface, the ectoderm, mesoderm, and endoderm. So at this point, what we'll be talking about today, we'll be talking about the ectoderm. So the ectoderm will differentiate into 2 points. It will give you, this is the ectoderm at this point. I'd like us to appreciate the ectoderm, then the mesoderm, the one in brown, and then the one in yellow, that's our endoderm. Then you can appreciate the notochord is actually at the center. Yeah, there, between the mesoderm. So meanwhile, someone can just tell us what are the functions of notochord, 3 or 4 functions of the notochord, as we talk about this mesoderm at this point differentiating into three locations. So you'll have three regions. So you'll have the paraxial mesoderm, the mediate mesoderm, and then the lateral pit mesoderm. Today we won't be talking about endoderm, we won't be talking about mesoderm, we'll be talking about the ectoderm. So you'll appreciate something interesting is happening to this ectoderm. You'll appreciate that it is undergoing folding. So that is our ectoderm. It will undergo folding to give us a neural groove. Then the neural groove, the folds will fuse to give us the neural tube. Then after having the neural tube, now at this point you'll have differentiated between your surface ectoderm and your neural ectoderm. So at this point, this thickening becomes the neural ectoderm. Then the thickening goes ahead to form the neural groove, the neural groove. At the folds, they usually fuse to give us a definitive neural tube. So the surface ectoderm will remain, and then the neural ectoderm will differentiate, will be formed. The neural tube will be formed. So I can see some responses. Yeah, so gives the trilamina embryo its structural support exactly, induces formation of the neurotube, correct. And then acts as a basis of formation of the exoskeleton, induces the formation of the neurotube. You guys are correct. So that's very, very much correct. Um, Now on these other images, you can appreciate now the formation of during now the lateral folding. During the lateral folding, how you'll have the incorporation of the endoderm, which gives rise to the gastrointestinal system and also the respiratory system. So you can appreciate how it's incorporated into the body. But that's a discussion for another day. Meanwhile, I'd like us to talk about the origin of the nervous system. So it comes from the ectoderm, as we saw. So this is ectoderm, it will differentiate into a neuroectoderm, and the remaining portion will become the surface ectoderm. This neuroectoderm will undergo neurulation, as we'll see, and then this neurulation will give us neurotube and then the neurocrest cells. So majorly that is what we'll cover at this point. And then after now having the neurotube and the neurocrest, this neurocrest will migrate to various locations. They'll migrate to almost everywhere in the body, including the skin, including the endocrine system. So we'll see all those derivatives in a few minutes. Yeah. Then I will also like us to appreciate and start us with the point of what is neurulation. So neurulation is a process of formation of the neurotube. So how do you have the process of formation of the neurotube? You'll have now the surface ectoderm, the ectoderm itself differentiating to form the neuroectoderm. Then the neuroectoderm gives you the neurotube. So you'll appreciate the neurotube that will be formed from this neuroectoderm will be the prepodium for both the CNS and the PNS. Given that the CNS, the central nervous system, and the peripheral nervous system will come from the neurotube, you'll appreciate all the structures, the brain, the spinal cord, the cranial nerves, the spinal nerves, and even these peripheral nerves, the sciatic nerve, all of them will come from this neuroectoderm. So just imagine you have the three germ layers, and then for these three germ layers, imagine you have a longitudinal cross-section. You have this longitudinal cross-section. So in this longitudinal cross-section, what you'll have similarly like this. So this is a primitive streak at this point. This is a primitive streak. You can appreciate this is a notochord. Ideally, this is a cloaca, this is a stomodium. So what will happen at this point is that for you to have the three germ layers, you'll have now the cells of the epiblast going into the primitive streak, and then they get this motile ability to move to various locations. That's the reason why now you ideally you have the two germ layer, the two epiblast and hypoblast. Then after some time, through the primitive streak, the cells of the epiblast will migrate downwards. And now, first of all, they come and displace the hypoblast cells to give the endoderm. And then after that, we'll have now the cells that are also migrating to fill up this middle space to give you the mesoderm. So that's the process of formation of the three germ layers, process of gastrulation. So after having now the gastrulation, we'll have the ectoderm. First of all, you have the notochord here. The notochord induces the formation of the neurotube, as we rightly mentioned. So this notochord will induce the ectoderm that is just above it, first of all, to thicken. When it thickens, it becomes uh, the the neural plates. Then after having the neural plate now, the ends of it will grow faster. They will develop faster, they proliferate faster to give us this neural groove. Then the folds will fuse to give us to give us a neurotube. But at this point, just know that neurulation is the process of formation of the neurotube, and then this neurulation will give us CNS and PNS. So we have three types of neurulation. We have primary neurulation, secondary neurulation, and junctional neurulation. So we'll see what are these three types of neurulation and how do they come across. So we start off with primary neurulation, and this primary neurulation is the one that now will come from notochordal induction. of the overlying cranial ectoderm. So primary neurulation will happen on the cranial ends, secondary neurulation will happen on the caudal end, and then the junctional neurulation will happen to join now this neurotube that has been formed by primary neurulation and also secondary neurulation. That is the reason it's called junctional neurulation, because it's joining the primary neurulation neurotube and secondary neurulation neurotube. So I hope you get that concept. At this point, we've already talked about this primary neurulation coming across due to notochordal induction of the overlying cranial ectoderm. So what happens is that, first of all, this is a notochord, this is a mesoderm, this is the endoderm, this is the ectoderm. So we'll have this notochord inducing this ectoderm to become a neural plate. So you can appreciate the notochord induces the surface ectoderm, the ectoderm to become a neuroectoderm. That's the reason you have these neuroplates. The thickening becomes the neuroplates. So the thickening is coming across due to induction by the notochord. What happens after that, you'll appreciate that you have a groove being formed. And that groove is known as, due to the thickening, we'll have now the groove, the neural groove. And then after thickening, what will happen is that you'll have more folding happening. So more folding happening. And then finally, the folds, the folds at these points, they'll fuse to give us a definitive neural tube. And then after that, we'll have the cells at the folds. So these cells at the folds, they will move. They will not form the neural tube, and they will migrate and form these cells. They will disintegrate and become the neurocrest cells. So these neurocrest cells will form a very important structures in the body, as we'll see in a few minutes. But that's a simple process that you can have. You can talk about. You have the notochord inducing the ectoderm. The ectoderm becomes weakens to form the neuroplates. Then the neuroplate ideally forms a neurogroove. And then this and this shows us the neurogroove. Then the neurogroove, the neurofolds will fuse to give us the neurotube. And then the cells at the folds will disintegrate to give us the neurocrest cells. That's primary neurulation that is happening cranially on the cranial part of these three germ layers. So that's it. I presume I've talked about this summary, ectoderm becoming neuroectoderm. You have neural thickening giving you the neuroplate gives us the neurogroove fuses to form the neurotube, and then the neurotube, and the cells at the folds will become the neurocrest cells. So you can be told in an AS exam, maybe with an aid of a diagram, describe the process of primary neurulation. So this is what you're supposed to do. You're supposed to draw that and also maybe describe that using those points. What about secondary neurulation? So for secondary neurulation, this one is coming from mesenchyme. So this one won't have any induction, would have any induction from the notochord, but this neurulation by mesenchymal condensation and transition from the caudal mesoderm. So a point to appreciate is that it's coming from caudal end. So how then does it come across? You have the ectoderm, you have the mesoderm, and then you have the endoderm. So it's coming from mesenchymal condensation. Then remember earlier what I had told us is that mesenchyme is undifferentiated mesoderm. So you have the cells of the mesoderm here. First of all, they are mesenchyme because they are undifferentiated. What will happen is that they will condense. Let's appreciate the condensation. This is a condensation happening in this image. Then after having condensation, we'll have, okay, this condensation now, giving us now the medullary rod or the neural rod. So medullary rod or the neural rod, still the same case, you'll have it there. Then another important thing will happen. We'll have cavitation happening. So cavitation will start to happen. And then after having now the cavitation, you have now a definitive neurotube. So you formed primary neurulation, you formed your primary neurotube, you formed your secondary neurotube. So that means they are separate from one another. So what will happen is that you need to have another type of neurulation. Now joining this neurotube from secondary neurulation and the neurotube from primary neurulation to which is known as the junctional neurulation. So secondary neurulation forms the neurotube, and actually this is important, that forms from the region from S1 downwards. So then the spinal cord that is being formed from S1 downwards will be coming from secondary neurotube. Then the rest now from L5 going ahead now, going above proximally, up to where you have the brain, the cerebrum, the cerebellum, all of them will be coming from primary neural tube. So maybe that's a sample way for you to know the differences. First of all, you need to appreciate and know how to draw secondary neurulation, how it comes across. That's just a simple and a simplified way to write your essay regarding secondary neurulation. So you have, first of all, you have mesoderm. These cells are differentiated cells of the mesoderm are known as mesenchyme. Then this mesenchymal cells undergoes condensation to give you the neural rod or the medullary rod. Then after that, we'll have cavitation happening in this. So cavitation means you'll have a cavity inside that neural rod. And then when you have just cavitation, you'll have the neural tube being formed. So, maybe I can give us an assignment to go and check when we talk about uh, mesenchymal epithelial mesenchymal transitions. What do we talk about? So, given the fact that at this point we have the mesenchyme, and then we want this neural rod, which is epithelial in nature, we'll have mesenchymal epithelial transformation. And how does it come across? Maybe you can go and write an essay regarding that. It's not important, but you can go ahead and check what does it mean and what location do we have these mesenchymal epithelial transitions happening. So a sample way to differentiate between primary neurulation and secondary neurulation can appreciate in primary neurulation. You'll have initial epithelium, then you'll have columnarization, which means the thickening, give you the neuroectoderm, then you'll have the rolling stroke, the folding, uh, to give you the groove, then you have the closure is daily diffusion, and you'll have the neurotube, which is complete. But this at the end, you'll have dispersed mesenchyme, the mesoderm. You have mesenchymal condensation. After that, you'll have the medullary rod. That will have now the cavitation. And after that, we'll have the neurotube being complete. So some of the differences that you can note in this is that one of them is coming from ectoderm, the other one is coming from mesoderm or the mesenchyme. One of them has induction from the notochord, the other one doesn't have induction from the notochord. One of them will form neurocrest cells, that is, primary neurotube will form neurocrest cells. The secondary neurulation won't form the neurocrest cells. Another point to appreciate is that secondary neurotube will form the spinal cord only. Primary neurulation will form the brain and the spinal cord. Yeah. So those are some of the differences that you can note regarding primary and secondary neurulation. Maybe you can also go through them at your own time. Then we go and talk about the neurocrest cells. So for the neurocrest cells, we can appreciate that these neurocrest cells will have specific characteristics, which are, first of all, they are migratory. They have anteroposterior polarity, and then they are undifferentiated. They can form any structure. Some of the characteristics of these neurocrest cells. So they are migratory, they are undifferentiated, they have anteroposterior characteristic. For the classification, this one is a little bit complex. You can go and check the various classification of neurocrest cells. So starting with the anterior vagal neurocrest cells, the cells that form the celiac region, the cells that form the pharyngeal cells, all those classifications, can go and check on them. Then, of course, now role in development, ideally, you're talking about the derivatives. So for the derivatives, you'll see there's some endocrine derivatives. You have integumentary derivatives. You have enteric system and derivatives. You'll have even peripheral nervous system derivatives. And then after that, I will say, if you have failure of migration of these neurocrest cells to those regions, which anomalies will you have? So, and the associated anomalies. So these are congenital anomalies that will be happening at those points. So, and maybe we can just mention maybe what are some of the anomalies that you know that are associated with neurocrest cells? I know some of us have read ahead a little bit, and some of them we saw them when we were talking about the development of the integumentary system. So, which anomalies come from neural cells. So um, Rachis cheeses, ideally, that's not an anomaly of, uh, okay, it's an anomaly of neurulation, but it's not an anomaly of neural cells. So albinism, Jonathan, you're correct. Aganglionic megacolon CM, you're correct. Melanocytic nevi, you're correct. You can even go ahead and start with the simplest one, which is albinism. So albinism is coming from neural cells. So yeah, vitiligo, all those, yeah, like if you affect the melanocytes, which are coming from neural cells, you're correct. So Rono also, you're correct on that bit. But we'll see them in a few minutes. Um, so these neuropres derivatives on the peripheral nervous system, we have DRG. So maybe someone can tell us what is DRG? What is DRG? Like according to what you learned last week in your histology sessions, what is DRG? Yeah, dorsal root ganglion, correct. Dorsal root ganglion. So the cells of the dorsal root ganglion, you have two cells of the dorsal, or have three cells of the dorsal root ganglion. What are the three cell types of the dorsal root ganglion? So maybe we can have questions from also all of us who are in the group. As maybe you put what are the cells that are found in the dorsal root ganglion, we'll see that the receptors of the receptors, all the sensory receptors. So talk about the free nerve endings, talk about the Meissner's receptors, talk about Pacinian receptors. So we'll cover this maybe the other week. We'll appreciate that all of them will be coming from the neural cells. Then you have enteric nervous system. So the enteric nervous system is the cells, the ganglions that are found in the GIT, in the gastrointestinal system. So remember, the enteric nervous system is like a special branch of the autonomic nervous system. So the GIT controls peristalsis, migration of food from one location to another, opening and closing of various sphincters, majorly by this enteric nervous system. So the ganglions of the enteric nervous system will be coming from neural cells. So let me see what are some of the cells that you've mentioned. So we have stellate cells, correct? Satellite cells, correct? Then you have this, so cell bodies can be cell bodies of satellite cells. Also, you can have cell bodies of pseudounipolar neurons. Yeah. So also talk about Schwann cells. So Schwann cells, pseudounipolar neurons, neurosatellite cells, all of them will be coming from peripheral nervous system. So kindly note down that so cells of the DRG, Schwann cells, your pseudounipolar neurons, and also we'll have the neurosatellite cells will be cells that will be coming from neural cells, and then receptors, then the enteric nervous system. Um, well, then we'll go ahead and talk about in the endocrine system. So in the endocrine system, we'll have parafollicular cells. So parafollicular cells of the thyroid gland that actually produces calcitonin that enables the regulation of calcium. Some of the cells that will be found in the endocrine system. So of course, we'll have other cell types that will be there. Go and check what are the other derivatives of the neural cells in the endocrine system. The integumentary skin, we have this MM cell, so melanocytes starting with an M, and then macular cells also starting with an M. Uh, they'll be derivatives of the neural cells. That's the reason why if you have absence of migration of the neural cells into the skin, you have albinism, or maybe you have an anomaly affecting the skin pigmentation. So melanocytic nevi, the vitiligo anomaly. So those anomalies that we usually talk about will be there. So ideally, for you to know how these neural cells have anteroposterior characteristic, you need to understand when we talk about uh, epithelial mesenchymal interaction. So if you know what is epithelial mesenchymal interaction, just tell me, then I'll describe. So if you don't know that, kindly I'll just request you to save on time. You just go and read that, and maybe you can ask that question maybe later. Because I presume right now you haven't covered that much. You are now introducing your concept on neurulation. So you need to first of all understand what is mesenchymal epithelial transformation or epithelial mesenchymal interaction for you now to know the characteristics of those neural cells. Okay, so we now go ahead and talk about the various cardiovascular in the cardiovascular system. We have great vessels. When we talk about great vessels, we talk about now the aorta, we talk about the pulmonary trunk. So the septation of those great vessels and even septation of the right atria, the atria, ideally those cells will be coming from the, the neural cells. So you can just imagine if you have now an anomaly that is affecting or maybe a failure of migration of those neural cells, that person will have cardiovascular anomalies. And then the last one is now craniofacial region. So all the structures that you know of the head and neck region. So talk about the mandible, the maxilla, the nose, the ears. Talk about um, the lip, the tongue, all those structures will be coming from neurocrestals. So the neurocrestals of head and neck will form first of all mesenchyme, and then they'll also form the ectoderm uh, of those regions. So talk about everything that will be formed at that point will be coming from neurocrestals. So even the teeth, the odontoblasts, those cells, the odontoblast cells that will form the teeth, um, all those cells will be coming from neurocrestals. So everything of the head and neck region be coming from neurocrestals. That's the reason why for a person who have maybe facial asymmetry, person who has maybe smaller mandible, the person had an issue to do with migration of neurocrestals into the craniofacial region. Yeah, so you can list so many structures here. That's the reason why if you're given a, maybe an essay to maybe talk about, describe the neurocrest derivatives, like you can have more than 50. You can have more than 50 answers in that. Then anomalies now associated with the neurocrest cells is that you have mechanism of these cells that you can have defective migration. In addition to you having defective migration, you can also have absence of induction, maybe primary neurotube to give you the neurocrest cells. Yeah, then anomalies, you can have congenital ganglionic megacolon, that is Hirschsprung's disease. We'll see it. So in this Hirschsprung disease, the person has a larger colon, like it's called megacolon, like the sigmoid colon, and then the descending colon is bigger because we did form the ganglion, so that's the reason we call aganglionic absence of ganglion cells. Then you have conotruncal septation defects in the cardiovascular system. Then you'll have fast act syndrome. It has defects that are coming due to uh, absence of migration of neuroplastic cells to the head and neck region. Then you have disorders of skin pigmentation, starting with albinism, and the rest that you mentioned earlier. So, which anomaly is this? So you can put your answer in the chat box as we move ahead. So the first person gets it right, albinism, you're right. You can go to the next one. Um, what about that? What anomaly is this? Okay, it's written there, so it's Hirschsprung's disease. So it can affect in this person, like the person has ganglionic cells. So absence of these ganglionic cells coming from the neuronuclear cells will give you Hirschsprung's disease or congenital ganglionic megacolon. Um, then this one now, I presume this one, and maybe you can have some people knowing about it, but you can appreciate this is the first act syndrome. So this person has a smaller mandible, uh, which is known as micrognavia. Micrognavia is a smaller mandible. Yeah, micrognavia, you're right. This is micrognavia. Then for the other one, you can have this. So this is tetralogy of Fallot. So this anomaly that is coming across due to absence of neuronuclear cells, so that you'll have an abnormal septation of the great vessels and also of the right atrium, of the atria, the two atria. So you'll appreciate that this pulmonary artery, the pulmonary trunk is not supposed to open ideally at this point, together with this um, aorta, ideally is supposed to open on this right ventricle. But now you can appreciate due to that, it's actually opening on also the right ventricle. So due to this defective septation that is happening here. So that is it. So for the neural tube now that we have right now is that you have already formed your neural tube. At this point, it's a still, so it's open on both ends. So given the fact that it's open on both ends, you will have neuropause. on both ends. You'll have the cranial neuropole and then you'll have caudal neuropole. So those neuropoles enables the neurotube to communicate with the amnion. So the cranial neuropole close on day 25, so or around day 25, day 24. Then now on the caudal neuropole closes 3 days later. So if you talk about it closing on day 25, the caudal one now will close on day 28. The cranial one can close on day 24. So that means now the cranial one and the caudal one will close on day 27. So those differences that you can talk about. The cranial one closes on day 25, then the caudal one closes on day 20, 27, 28 there. So that is it. You can appreciate these are longitudinal cross-section, showing us, first of all, these are the neurofolds. The neurofolds are fusing. And then at this point also you can appreciate the neurofolds are fusing, or at this point you have now the caudal neuropole and the cranial neuropole also shown here very well. The cranial neuropole and the caudal neuropole. So these neuropoles will communicate with one another. Now it's with the amnion. This amnion now will contain the amniotic fluid first. So and then they will close on day 25 and day 28 respectively. Of course, there can be variation. It's usually plus or minus 2 days. So plus or minus 20, plus or minus 20, 24, plus or minus 2 in, so you have for cranial neuropole, you have plus or minus 24. And then for caudal neuropole, you have plus or minus 2 days from now, 3 days that were previous on this day 24, day 25. So that's just a simple illustration showing us. Then for the neurotube derivatives, and then at this point, I'll just like us to maybe talk about these derivatives of about this neurulation thing. Before the 4 minutes, so we have 4 minutes at this point. And for the 4 minutes, maybe we can have some few people asking some few questions, and then maybe we'll come back after maybe 5 minutes and then go ahead. So any question at this point? Any question at this point? Or maybe before you ask your question, so maybe what's the embryological basis? Because in an exam setting, you can be told, what is the embryological basis of albinism? So the embryological basis for albinism can be, you talking about, it can be failure of migration of neuronuclear cells, or to give you the melanocytes, or these melanocytes, they're not having now the various products for you to form albinism, but for you to form the melanin. Then you can have now for the Hirschsprung's disease. For the Hirschsprung's disease, ideally failure of migration of the neuronuclear cells towards the sigmoid colon and then the CD colon. So you'll appreciate that this person with Hirschsprung's disease is actually manifests itself in the earlier stages, in the earlier years. So you'll realize that this child, this kid, has an enlarged bowel. Yeah, a distended bowel. Then for this person who has maybe lower mandible micrognathia, is coming across due to abnormal migration or abnormal formation of the pharyngeal arches, which tries to raise mandible and also the maxilla. And also at this point, you can appreciate there is facial asymmetry. Like this side is larger than this side. So this syndrome is known as golden hair syndrome. And then also you can appreciate like this person has enlarged ears. So now neuronuclear cells, they went ahead and formed like, they didn't form well. The ear well. So given even the ears are coming from the neuronuclear cells, it just tells you everything. So Kisaka, kindly avoid doing what you're doing. Then also you'll have now the conotruncal septation defect. So one of them is tetralogy of a low persistent truncus arteriosus. All those structures, all those anomalies should be coming across due to that. So I can see maybe you have some few questions. Okay, ideally they were just answers. So dormant melanocytes, you're correct. It can be dormant melanocytes. So that means melanocytes are there, but now we don't have, we have maybe failure of action of tyrosine enzyme in the melanocytes, correct. So you guys are correct. Um, I presume you can take maybe a break of maybe 2 or 3 minutes. Then after that, we'll come back and go ahead with the discussion. So someone is requesting me to repeat on this Hirschsprung's disease, or how does Hirschsprung's disease come across? So remember we talked about the derivatives of neural cells being the enteric nervous system. And then the enteric nervous system is the one that is responsible uh, for the movement of foods, may it be in the esophagus, in the stomach, in the small intestine, in the large intestine, in the rectum, all that. So if you have now absence of migration of those cells, of neural cells to this GIT, to give you the enteric nervous system, you'll appreciate that now you'll have accumulation of food in the GIT. So due to that, now we'll have enlarged bowel, giving you now the Hirschsprung's disease, which is congenital ganglionic megacolon. She can take a break of 2 or 3 minutes, then we'll be back.